Welcome to part 7 of this little series of me trying to assemble or trying to design my own 3D printer. Yeah, last time we had a big success. We finally had a working gantry after 2 attempts, or the second attempt worked. And yeah, so today let's kind of start moving up a bit. And my goal is basically not to fully build the Z-axis. I didn't design any parts. But my goal is basically to figure out how the Z-axis can work. So basically what I did is I designed 2 small parts. One is this temporary joint, where basically we can just put together 2 rods in a stable way. And the other part is basically this piece where we can join the rod to a linear bearing. And my goal is basically just to create a working motion system for the Z-axis using those 2 parts and all those rods we have here. I didn't cut them to length. The benefit from the setup is basically we don't have to cut anything. So we can just try out and see what works. So yeah, I have all the parts printed, so we'll have to assemble these and then just start building everything together. Hey there, Harlem. So yeah, that's that. And finally, after quite a bit of delays, I received the last parts. So I have now this box with all the parts we will need. Just quickly, we saw the power supply already last time. There's a lot of stuff we don't need anymore. There's some belts and yeah, a lot of junk. But what arrived is we now have a little NEMA 14 stepper. This one will be used for the tool head. So basically I decided now that we kind of try to build a decent printer first, let's not go for Bowden setup, but let's go just for standard direct drive setup. So we'll just use the full mini stealth burner with this motor. Still using a cheap hot end, but I don't think it makes a big difference for now. And what else did arrive? Oh yeah, so last time we also had a quick discussion which mainboard to use. And I tried flashing Clipper to the Ender 3 mainboard I had laying around, but yeah, it's a bit of pain. You need, because it's one of the older Ender 3 mainboards, you need a programmer, so you need to have an Arduino to program the mainboard. And it's yeah, I'll try for 20 minutes and I'll say, okay, whatever. So we use the SKR Mini, not SKR Mini, SKR Pico board in this build. What else? I think that's basically the parts that are new. Oh yeah, and I also got myself a Raspberry Zero, so I'll just use that. Should be enough. Together with the Pico, we can basically power the Raspberry from the mainboard directly. And we also need USB. We can communicate via UART. So the USB port on the Raspberry is free, either for a camera or for something else. So let's see about that. But yeah, so that's kind of the parts here. And you kind of maybe already saw. Oh yeah, I also have a little kit with parts for the extruder. Not too interesting. This one is the last major part that we were missing. So this is just bad for Prusa Mini. And yeah, just a normal PI sheet, nothing fancy, just kind of more or less cheap as I could find. This one's not original, unfortunately. I kind of feel bad for buying counterfeit Prusa parts, but the original one is 90 euros, I believe, and this one was 27. For this build, it should be good enough. But yeah, it looks quite good. It has magnets. Yeah, it's nice. The only thing that I noticed is the cable cover here has a broken part, but most likely we'll have to replace it anyways. It's a printed part already. So most likely we will replace it with something else because the angle might not quite suit what we need. But yeah, so this is actually something we want to use today already, in a preliminary way, but my goal is basically to use 3 of those mounting holes to mount the bed to our printer. Speaking of, it's a bit taller than last time. So basically what I did is 2 things actually. Let me see if I can Oh. Ah. I did not anticipate that. That's how high it will go. Maybe I have to find a new solution for it next time. So basically what I did is everything shrunk a bit down. So the rods we have on Y and on X, they got a bit shorter. So basically last time we had those 30 centimeter rods here, and I now replace them with 25. Reason's quite simple. The 30 centimeters are too long. Like not too long, but for the bed we have, just like said, like size comparison, 25s are perfect. We need to see how it like plays out in the end. We might lose like 2 millimeters on each side with like the movement. But yeah, not super concerned. I'd rather have 5 centimeters less in width and depth, and lose like 2 millimeters of like print volume. So basically all I did is like replace the rods. We had a couple of things that were not perfect last time. So I also reprinted those like motor mounts here. So basically all I did is like I made the tolerances tighter. Like they're sitting on those like rails here on the inside, so you can move them back to tension. And they were like a little bit too wobbly. So basically I just made the tolerances super tight. Now they're like relatively stiff to move, but it's fine. But they don't wobble anymore. So this is like now the printer wobbles and not the motor mount. What else? I think these were the only parts I replaced, and the rest was just like I had to rebuild it because I swapped out the rods, but it was not a big operation. It was done quite quickly. Yeah, and then of course, instead of like those little stubby things we had here, I now have the full height. Let's see how it plays out. I might consider also shortening those. Like these are now the 30 centimeter rods. I might consider putting in, I mean, I have 20, so this would be quite short because you also lose like a bit on the bottom right for the PSU and whatever. So maybe we use the 20s, or I ordered a couple more 25s, because I think it's nice if it's a bit shorter. Hi Neo, good evening. Looks good. Didn't catch the last live and missed the progress. Yeah, well, it's the progress is basically it's now moving. Like we have the motors in, and end of last stream this was moving on its own. If you check the community tab of my YouTube channel, I also posted like a small GIF how it's like moving in a rectangle, basically, or in a square. But yeah, so that's kind of like where we are today. So yeah, I don't really have a plan. The goal is really just to figure out how we can put the Z-axis in. So basically, I think let's just start by assembling those like temporary helpers. I think we have like 6 of these and like 3 of these or something, so we have to quickly go through and do that. And we also have the old ones. These are like X clamps basically, and these are like T clamps. But I don't think we can use them or we don't need them. So we have to just quickly build that. That will be 5 minutes, I guess, hopefully. And then I would just use like the pre-cut rods. We'll do it, yeah. And then just like kind of like preliminary assemble everything, and then try to put the bed somehow in there, and try to get smooth motion. My concern is a bit, so ideally we only use the 2 rods on the front, but I'm almost certain that the bed is too heavy to only like be held up by like those 2 rods here. So potentially we have to somehow like MacGyver extra rod somewhere here in there, to stabilize the bed in the back as well. So let's see how it goes. And I guess enough talking. Oh yeah, I also reprinted this little clamp part. That's the end stop here. So basically now it's moving all the way to the side. So now the button triggers here, but it's like there's not a big gap anymore. So we don't lose any print space there. Yeah. And And oh yeah, the only thing that did not arrive yet is my new heatset insert tool thingy. We broke the heatset insert tip last stream while trying to disassemble or like pull out a couple of heatset inserts. So we have to make do with the normal tip. So it will be fun. I know, like, I assume, let's just quickly check. So these are all parts that don't need heatset inserts. And I think these are also, oh yeah, some do, some don't. These do. So these do. And these don't. Okay, so that's basically our to-do list. These all have 1, these have 2, and these have 4. So I don't know, let's start with the 2s, I guess. So basically, like, from design perspective, the next step is really to design more or less the entire bottom part. I don't think we can really break this down in any step, in any way. Because basically the x-axis, the z-axis will need to be supported on the bottom somehow. I mean, if we manage to only, oh, this one's not straight. If we manage somehow to get along with, or like if we manage to only use the 2 front parts, I think we can completely design the bed first without worrying about like the skirts and the bottom part. But if we need to put in a rod in the back, I fear we also have to kind of design the skirts together with the z-axis. So see, I'm really curious because I have no idea how that mechanically behaves now. I never used rods for z-axis. I know like a lot of printers do that, but I never had a printer that did that. So I'm not quite sure, like, I'm just concerned that, like, because the center of gravity is so far out of the rods, that we definitely need a 3rd one just to stabilize it in the back. And then the only thing I'm certain about so far is we will use a belted z-axis. So basically on the back we'll have motor with a belt. So we won't use a lead screw. Oops. I don't need Nick. I really should start finding ways to design parts with less heatset inserts. I feel like I completely overdo it with screws. Like, most likely those 2 would be fine and it would still be stable. And I'm still considering building a heatset insert press. Would make the entire process much more enjoyable. Half done, I guess, almost. And the heat, like, using this tip is horrible. Like, all the inserts are like crooked. The new one should arrive next week. Kind of forgot to order that until I think Tuesday. Completely forgot that I broke that. I mean, putting in all the heatset inserts kind of has something peaceful. It's a very like relaxing word. And I guess the next step would just be to like kind of put them loosely together. That we just put them in the screws, but don't tighten them yet. And then later we can just slide them onto the rods. I think that makes the most sense. I'm not quite sure if it's like easier to assemble them like in place when we need to like put the rods in. Yep. And these are all the recycled heatset inserts. Now we have to get some fresh ones. That's also why some of the heatsink inserts have like some blue bits and black bits on them. It's like we pulled them all out of parts. I will set self-press heatset insert tool. Yeah, I'm also looking at that one. It was easy to self-source and works great. Yeah, I think the self-press is a bit overkill. It has a linear rail, right? I actually had, or like have all the parts. What is it? It's like super old. Like there's from Adafruit, I think. They also have this like heatset press design. And I have all parts for that here. It's just uses like a bit of like 2020 extrusion. And yeah, some 2020 extrusion. And then just the Wii rollers basically, and some some hardware as counterweight. So I consider building that because I just have all the parts here, but then I need to get, the only thing I don't have is a second soldering iron. So that would be the only thing I need to buy. But I guess like some cheap 15 euro Amazon soldering iron will be plenty good. But generally I don't mind putting heatset inserts in. It's just like now that I have to use this like standard soldering iron tip, it's kind of painful. Yep. But we made it. All the parts. Okay, I think it's really a good idea to just like quickly assemble those. So it's really just like those three parts, like the top and bottom are almost identical. Just one side has heatset inserts, and one has this screw hole, or like the hole for the head of the screw. Yep. Why does that not fit? I'm just curious. Here it doesn't fit. Let me try another one. Maybe we have to live without the blue part. Oh wait, we are missing heatset inserts here. This one is one with heatset insert. Oh yeah. The blue parts don't fit. I made some mistake there. Okay, yeah, we don't need them. It works perfectly fine without. Just doesn't look as cool. Then I guess we just do it bare bones black. Interesting, like the holes just don't align. They're like ever so slightly off. So also don't forget to put heat signatures in here. I think that, yeah, that's the only one we overlooked. If you can get the iron with a thin metal barrel, I started with the cheap Amazon special, but the metal part got in the way of tricky parts, like some of the Clockwork 2 inserts, pencil. Yeah, the pencil is quite good. That's also what I heard. But yeah, I think mostly it's fine. Like if there's like super tight spots, like I can always fall back to just using words, a lighter and a screw. And just like heat up the screw with the lighter, and then you can just use the screw to push it in. That also works pretty well. That's what it did for the stealth burner in a couple of spots, a mini stealth burner in a couple of spots. It's like almost small mass production here. I just hope I have enough of those parts. I counted it in my head, and I think I added two extra ones. But now that you say it, like actually it would be nice to have a pencil. Maybe I also use this one then in the press and just have a pencil as the main soldering iron. I think they're quite good. Like at least I only hear good things about them. Oh, wrong screw. Yeah, we'll struggle a bit with tightening those screws. Like all the heatsed inserts are crooked. Yeah, it's just like temporary parts, so that's totally fine. Just has to work for today, and then we can design some pretty parts with straight heatsed inserts. And I guess the first step would be just like to quote unquote secure the bottom, and then we just like build like a square on the bottom. I'm also curious to see like once we like add all the extra like rods, if the printer becomes stiffer, because right now it's a bit wobbly. So it would be interesting to see if this has like a big positive effect. More. Yeah, and this one needs some heatsed inserts. hope we didn't forget any, and these are the last for today. For the root printer, they had a lot of issues with set binding. When using 4 rods for Z movement that uses a small V0 bed, so they ended up switching to using 2 Z rods. Yeah. So the thing is, like for me, I try to use 2. That's the goal for today, to figure out whether we can use 2. If we need to use more than 2, we will use 3. I'm not going to use 4. But yeah, let's see. That's really like the still need those. The goal for today, just like to figure out like what is the configuration of the Z-axis, and then we can like design some pretty parts around it, and really like go in the last stretch of this build in a certain sense. Like from the difficult part, for me, is really like the motion systems. Once we have a working motion system and X and Y is working now, I'm totally confident the rest is basically a walk in the park. Cool. Okay, that's all the joints. Let's actually also quickly like free up this one. And then basically now we have to build these. So these are a bit, we have a couple of options here as well for those. At the moment I configured this with like one bearing in the middle. What we can also do is like push it halfway out and have 2 and see if that helps. So from my research, which I'm not sure what it's worth, basically the main problem we will face is the center of gravity is way off. So basically if we use 2 rods, the center of gravity is like off axis basically, and this also can cause binding. And that's like why with 3 rods, that's not a problem, because then you have support on the other side. Another option I was thinking about, but I'm not sure if it's good or bad, is to use 2 rods. Oh no, there's some stuff in the thread. Another option was like to use. No, 1 second. There's some plastic or something in the thread. Yeah, now works. The other option was basically to use the 2 rods in the front, but then have the belt in the back. That you basically have support in the back. But then I'm not sure if that is helping, because basically then you're also like having like let's say like the bearings are on this side here, and your the bearings are in the front here, and you're pulling on the other side. So basically you're also like kind of like forcing it in a certain way. So I'm not sure if this really helps. But yeah, that's basically just trial and error now, I guess. Kilk. So I think I always mispronounce your name. I'm really sorry. So here are 2, and this is the last one. I withstood the urge to add 2 more screws here. So I'm trying to get better with my excessive use of screws. Okay, I think these are all the parts and all the screws, minus these. I mean, technically we can also quickly put in some screws here. There's also a part I'm curious if it works. So basically the idea is to have it on the rod. We squeeze it on one side, and then the bed will be mounted on this side. So yeah, that's the idea. I'm not quite sure if this will work, or whether we have some problems with this part twisting around the axis. Okay. All parts assembled. Off to the fun part. You just make some space. It's okay, yeah. I'm sorry. No, it's cool, I guess. So here it is. I really need to find like a new solution for the camera. Like this arm, like it's a bit wobbly, which is mainly the table. It's also like kind of like limiting from a reach perspective. I'm thinking of building a 2.4 later this year, and for 2.4 this is not working. I guess we kind of have to shift a bit, maybe the perspective. Maybe this works better. Then at least you see the entire thing. Oh. Okay, so I think the step one is for the front rods. We kind of need to put the linear bearings on, because otherwise we will not have a chance to do so later on. And let's also maybe already connect them. I'm not tightening that yet, but just... Yay, it's a Z-axis. So you are using printed bearings for the rod? No, these are just standard LMU88 bearings. We experimented with printed bearings in the beginning, but it didn't work, and I'm still not 100% sure why, but I think it has partly to do with the force of being applied to the bearings. That's the same. I don't have them here at the moment, but like those LMU88 bearings made from plastic you can purchase. They have the same problem. There's this, I think it's called 2-to-1 rule. So basically, if you have the bearing on this axis, the spacing, like if you have two bearings on one axis, the force can only be twice as far away as the distance between the bearings. I think that's a problem we ran into using the printed bearings. Because the printed bearings or plastic bearings in general, they seize up. If you exceed this 2-to-1 rule, they just seize up. Whereas the ball bearings, they just get harder to move. So I think that was the problem. I read about someone using patchy printed bearings and some sort of lubricant. Yeah, so I tried ABS and I tried PLA. I didn't try patchy, but I don't think it would have made a huge difference, to be honest. Maybe long term the others are better, but yeah, short term I don't think would have mattered too much. So let's just we all put them together in slightly different ways. I didn't pay attention, but yeah, it's just a test, so it doesn't really matter. And I guess we can just tighten them. 2 screws per block here would have totally sufficed. No need for 4. But it looks nice and symmetric, so. Let me maybe put even like that for now. And maybe even like that. Makes everything easier. Yeah. I didn't put in the heatset inserts straight. That's a bit funny to tighten those. Also interesting, like it tries to pull itself a bit off the rod here, so I don't think that things are not super straight or square. I think that most likely means that this rod is most likely not fully inserted on top. Maybe we can quickly check and see if we can correct that. Just quickly loosen that here. I think it's all the way in. Okay, maybe the rods are also slightly different. But it's quite significant. Yeah. Okay, let's ignore it for now. But it works already quite okay. Like it's not tightened yet, so it might get worse, but for now it works okay. Let's do the same on the back. Let's see, like we need 2 more here, right? And then we need two more. Oh, yeah, see, I didn't print enough, I think. Because we need at least 1 more here. Okay, maybe we have to remove those later on, but that's okay, I think. Let's do the front back first. Which is also not super smart, because I wanted to have the front back on. I mean, let's move this up slightly. Let's see if we can. Yeah, oh, I'll just squeeze it up a bit, and then we can put this on, and we can put it all through here. Here we go. Let's already do the same on the ups, like on our side. Hi there, Marcin. I'm reading the description and just realized that those aluminum rods are from the hardware store. Yes, they are. I mean, not all of them. Again, like I tried to make a very cheap build in the beginning, which kind of like failed. But basically the rods that are used for linear bearings they are proper smooth rods. So you see this one is a bit glossy. The glossy ones are basically proper smooth rods. But the matte ones, the sandblasted ones, are just from the hardware store. And I think it works relatively well, to be honest. I mean, let's see how it behaves in the end. Switching them all for smooth rods that are like super straight is an option, but just makes the builds more expensive by quite a bit, I think. I tried to design the parts all in a way that they're quite tolerant towards the length, at least. And I think like for the very short runs we have, they are also kind of okay from like a straight perspective. But initially, like the idea was to only use the hardware rods, but then I just realized, oh, by the way, this is not the printer being super unsquare. My surface is curling. For some reason, like it starts like curving up a bit. Noticed before the stream. So. But I think the printer is already way stiffer. Like adding those 3 rods here on the bottom. And heavier. Yes. I'm not sure if this is now from the printer or from my surface, but doesn't really matter for now. As long as this is parallel, which it's not. Just feeling here on the side, which is definitely not parallel. But yeah, we have to tighten it on top, basically. This rod needs to be tight on top, and then we have to loosen it on the bottom, just like to adjust the width. We can do that in now. Let's just do it now. So let's just loosen one side here. Yeah, so maybe you see it here. This one is a proper smooth rod, and this one is from the hardware store. This one's actually hollow. I went through. Oh wait, let me go. My camera is a bit loose. 1 second. Nobody wants to use camera. Here we go. So I went through a couple of iterations of those rods. So first I had this one, which is sandblasted on the outside. Which is sandblasted on the outside. So this was an absolute no-go. Because like it was kind of sanding down everything that went over it. Then I had this one, which is pretty smooth, also hollow, both 8mm. And then the last one I had was this one, which is also smooth, but it's solid. So this one actually, like if I have to buy more, I'll definitely go for the solid core one. It's just like they're like way stiffer than the other ones. And they're actually cheaper for some reason. I have TechPrint Lab. Love this project, but I don't know where to find the STLs. They don't exist yet. Like I didn't publish them yet. Because this is like work in progress. I first have to kind of like have something working before I publish something. I will publish everything in the end. But I first need to be sure that this is what actually works. Because, for example, like until last week, right, the gantry was pretty different. Like not visually different, but like mechanically different. And it just turned out like it didn't work at all. So I had to reprint the entire gantry parts. So publishing the STLs now wouldn't make a lot of sense because they're still changing constantly. Also, like what I have here, like is most likely not the final form. Yeah, I'm just holding this up and tightening that in width. I assume the hollow rods require machining or a more complicated mold. Yeah, I assume so too. That they're just like more difficult to manufacture. It's also like the sandblasted ones are double the price of the smooth ones. Like the smooth hollow ones. So that the sandblasted ones are €3.50 per meter. The smooth ones are like $2.50 per meter. And the smooth solid ones are like $1.80 per meter. And I was just like, when I was like starting this project, like by far the cheapest way to construct like the frame, because everything else just either needs like a lot of printing material, like for example the Rook, right? Like the Rook has like a completely solidly printed gantry frame, or it's just like you need aluminum extrusions and stuff, and it gets relatively expensive quite quickly. Okay, so this one is loose. The bottom one is loose. I really need to find a new solution for the camera. So let's just tighten this one here. So basically we just copy the length of the rod here. And then hopefully after this is tightened, we can still smoothly move the rod up and down. Yeah, that works. No binding. I also saw this, speaking of cheap printers, I've never saw the channel before, but I randomly found this guy on YouTube who like was quite a big channel, like a couple 100,000 or million subscribers, and he welded like a frame that's just like a cube frame basically, and built a printer in that. It was like from the Philippines or something. So it looked super cool, which also is incredibly cheap because he just like used just like simple steel beams basically. But yeah, not really like something I can do here. Like I neither have space nor skills to weld my own parts. I saw it as well, yeah. A really cool project, like a really cool project. I really enjoyed the video. I think also subscribe to the channel, but I kind of forgot. Okay, so this is now what we have. So basically, I think I didn't quite think that through. Like for two parts, if we only would have the front one, we would need more than one in the front, right? So basically, let me just put it quickly together, and then I think it's clear what my problem is. I have to open this one. Tech Builder. Okay, yeah. It was for sure the first time I ever saw the channel, and I fully forgot the name. Okay, so I'm just using. This is like a 20 centimeter rod. Let's just add this here as a quick demonstrator. Yeah, and this is already a problem, but I think if I tighten it, it will be a bit better. Might even hold up. Okay, so basically the problem is, right, if we would have this as a standalone setup, right, so we just have the bed on the front and here, we definitely need two rods in the front for here, because otherwise this can rotate, and we don't want it to rotate, of course. Other problem I didn't think of, we have those parts which need to go on this rod. Shit. So you have to take one part off and slide two of those onto the rod. Was the same for me, just searched my history. Yeah, okay. I guess this video just like showed up on everyone's feed who is like into like building 3D printers and stuff. Okay, let me just quickly open this and then we can just slide this one here. Yeah. I should have printed more of those. Like if I would have like another one of this, we could have like stacked them together. That's a shame. Like I really wanted to try that. I think it's best to just quickly try and print like another one of these. Because then we can really just like test out. Because like having only two vertical rods would be my absolute preferred way of doing this. Okay. Still works somewhat okay, but really like it's not super square. Like, yeah, for now this doesn't really matter. Let's just quickly try it. So basically my idea now was to use like long screws. Hey. And then we have our standard yellow bed springs. Just checking, yeah, the V0 actually uses the same yellow bed springs. And then we just put it on top here. Not quite sure if the screws are long enough, I don't think so. The screws are not quite long enough. And the question is also if this rod that we put on here in the middle, if this is long enough. Barely. Barely long enough. Let's just quickly fix it in the front and then we can fix it in the back. Yeah, but I think like the screws are not quite. No, I mean, I have to really compress the springs to get something in on the other side. Let me see if I have something else. That we can use as a stand-in basically for the springs, because we just have to lift it up a bit. random spacer. But they're too tight. The screw doesn't go through, so they're too tight. See, what else do we have in my magic collection? Ah, you know what? Let's just use the bearings. We just use 2 bearings as spacer. I think you need the printed part that goes from the bed to the Z-rods if you're going to use 2. From the bed to the Z-rods. Yeah, this will definitely twist. So printed part is one option. The other option is, that's what like my initial plan, I kind of like screwed up. That's actually printed. We can also just use 2 rods in the front, right? Then they don't twist. I just like did not consider that. Let's just quickly see if we can get this to work in any way, shape, or form. But yeah, like this will definitely twist. I 100% agree. Like with 1, it's not working. We definitely need 2 rods in front. But then like with 2, it's also like you kind of lose that height in a certain sense, right? Because it's not an M3 screw, M3 nut. This one. Hey. Philly. Yeah, this will definitely twist. So my main goal right now is just like to see what happens if I pull in the back up. Is that like... Okay, but yeah, it definitely twists. Potentially twists so much that like we can't even test the motion. Like I really want to test the motion just now. I think we also need a longer rod here. Yeah, I don't think we have to continue that. So that basically is not stable enough. But then the question is like, does that work? That's kind of like my question. So my idea was to have the 2 rods in front with the bearings, where the bed rides up and down, but then basically have a belt in the back. The belt is pulling here. Let's actually quickly add it up here. Okay, so basically the belt would pull this up and down here. And I think this actually kind of would work, right? Because if I pull this up here now, that totally works. Because I don't feel any resistance at all. Benefit of not having like a rod in the back, right? Just like from a layout perspective, let's say we add a rod here, right? It's kind of a bit awkward because then we either need to mount it on the back rods here, so we have a big printed part going to the front, and on the bottom we kind of need extra rod here that goes through. So if we can manage without the rod in the back, I think we are way better. It's also like less binding potential if we only have two. The other side has some twists. It would probably work. Yeah, also a thing, but like you kind of don't want this to twist, right? Because if this twists during a print, if this would twist during a print, you would lose your level. So even if this twists like minimally when lifting, this kind of would be really hurtful, I think. But maybe the twist right now kind of like manipulates the result in a certain sense. Yeah, like it only moves smooth if I like have it here because of the twist. So let's maybe find a quick way to just stop the twisting motion as much as possible. Maybe we can just use some electrical tape around the rod just like to add friction. Aren't you going to have Z belts on both sides? No, only one Z belt. That at least that's my idea. Like this is really like just to validate the concept. So my idea was to have one Z belt in the center here attached. So let's quickly disassemble that again. Fix the twisting preliminarily and add the longer rods. So basically the idea is to have the motor somewhere here on the bottom. And then we need like something here where the belt runs over. Yeah, let's maybe quickly take this apart, fix the twisting, and then I can maybe better show what my intention is. But I think it will work. Like from what I just feel now here, I think it will work. The interesting follow-up question then is, would it also work in a bigger frame? Because like my idea is that you can scale this printer up and down a bit. You can basically, so this is like 25 centimeter rods, but you can also swap in the 20 centimeter rods, and then you have basically a printer in V0 size. So then you have the V0 print bed size. Yeah, let's just use something super long, doesn't matter. Okay, and let's quickly add some electrical tape around here. Why don't you try to print a beefy L bracket to support the bed from the back? Where would I mount the L bracket to on the back? Because then I would need like another motion system, right? Ooh. I totally scratched up that thing. Here, I'm sure you can see that. Here. So the chrome-plated rod is much stronger or like harder than an aluminum rod. Yeah. So PK, like basically, if I would support the back, right, I would need like another motion, like another bearing or something. And like right now, just try to check if I can get away without having that. So if I just have the belt in the back, just a belt supporting it, then I don't need another rod and another bearing. And my fear is a bit if I have another bearing, that stuff will start to bind up, because then it's like 3 bearings. Let's see, I'm just trying to space it out a bit. Just add a bit more. Just 1 bearing, 2 rods. But it's kind of what I have, right? I have 2 bearings now. Not quite sure if I understand the concept. Well, 2 bearings, 1 on each side, but 2 rods to keep the table straight. So basically 4 then, right? You mean basically have like the same setup what we have here on this side here. Oh, above, below it, yeah. That is also something I talked about. So basically, yeah, I only have 1 more of these parts at the moment. We could print 1, but technically we can just add another one here. And this would also work. The only thing is like you lose a bit of Z height, right? Because like this construction gets higher. For now, I think if I go for this like front only solution, then definitely we have 2 here. Or we replace this rod with some printed part, basically, so like that we don't have this twisting issue. Like this is just the test setup right now. I just try to figure out if my concept generally works. You don't need 2 bearings for 2 rods. Keep the same bearings and 1 more rod. Yeah, I got it. Basically, you want to have this, basically. This. Yeah. Basically, in a final or like in a production setup, this would definitely be the case. Today, I'm only trying to validate how the Z-axis could work. Because if I now start designing any like stuff, I feel like it will go horribly wrong because I just never tried the mechanics behind it, and I'm not an engineer, so there might be some super obvious stuff that I just don't know. So for me, it's always like I want to try it. Because like with the gantry, like we had the same thing. Like I designed it and it kind of almost worked, but not quite because I didn't try the concept in the beginning enough. Let's see. You would have the LMU bearings encased in the print part. Yeah, the LM8UU bearings are definitely encased. Like, I mean, at the moment they're kind of semi-encased, but this is also like a preliminary part. Let me quickly. This is like a bit tight now here with the electrical tape. So basically here we also have them fully encased, right, in the XY joint. Also here it's semi-encased basically. So I think it will look a little bit like this in the end. And also here, right, like we have the 2 rods. So technically we can just take this part, flip it, and we are kind of there, basically. Tightening this all around. I think this should, yeah, this fixes the twisting issue for our test setup today. Cool. I'm just not sure if this is now the correct position because it needs to be a bit off center. So basically, right in the end, we would have like some roller here somewhere. Let's just say this is our roller. And then the belt would be fixed to this rod here in the back. The belt would be fixed like this. Let's actually maybe just quickly do that. And we just grab 2 cable ties. What you do right now is adding friction. It should help, but there will still be rotation for supply. Yeah, definitely there will be rotation. Like this is just for testing the rough concept. This is not like how I will do it later on. This is really just like, I want to try if this works. This is my goal. If we get smooth motion in this way, I know that I can get away with this setup with like 2 rods in the front and the belt in the back. This is kind of like today's goal, to just verify that. If that works, we can start designing the proper parts basically. So this is really just like an experiment, like a test. Because I don't want to start designing the parts if I don't know if this concept works. Yeah, adding weight, that's exactly what I want to do. That's kind of like where the print bed comes in play also. There are magnets on the print bed. The sheet kind of was semi-attached. So basically I just want to like put this in place, put some weight on the bed, and then just see like how this behaves. Is it like smooth? Does it start to bind up? And then yeah, so it's just like a concept right now. And just like adding or learning is the important part. I'm really annoyed, like this is like super bent up, like nothing is straight here. I have to really fix that. I had the same issue in this corner at some point. And I have this heated blanket, and I put the blanket on top, heat it up, and put weight, like heavy stuff on the entire thing, and then like it flattens out again. Super annoying. I really have to look for like a different work surface thing. Technically it's a cutting mat. Okay. PK, compliments your comment. If you want to sell at the G4XY, you can suggest scavenging free office printers. There's a ton of them on Finalizing, and they have nice linear rails, and bigger one even name on 17 steppers. Yeah, it's like one thing is like, I mean, I just right now I kind of dropped the cheap requirements. Like I'm just using like normal printer parts right now. Later on, I think there are a lot of ways to get cheap steppers. Also cheap power supplies. Like you don't have to buy like a new power supply, right? For example, you can use like the old laptop power supply with 19 volts. That also will work most likely totally fine. Like if you use 24 volt power supply or 19 volt power supply, shouldn't be like a massive difference. Okay. Let's add some nuts here. 0.5 kilograms of PLA filament will do it. Yeah. I also have a water bottle here, which is quite heavy. But yeah, something like that. The question is realistically, how much filament would that have to carry, right? So if you have like a big print, how heavy would it be? My guess would be like tops 1 kilogram. Like if you have like this small print surface and you print like 1 kilogram of material, it's already quite a lot. So if we can lift like a kilogram with that, I think we are golden. Okay, let me just tighten this one here as well. I don't think this makes a huge difference, but yeah. So basically why I want to go for this T construction, like without the twisting problem in front, of course. But with this setup, I mean, the bed is also not centered, but it's not important right now. You can like any bed with 3 mounting points, you can mount on that, right? So a V0 bed, for example, would also work on the setup because you have 3 mounting points. So you can use the V0 bed for that, or you can use the Prusa mini bed. but you can also use a Prusa Mark IV or Mark III bed in that, because that's the same 3 mounting points. So if you want to like scale the printer up or down, that totally works, right? The only thing you need to do is like you need to change the length of the rods to match the print surface. That's like a bit of like the idea behind that. We still have this one clamp, so I think I'll just use that here in the center for a second to create the rotation point. And then we can really just put this over that and pull it up and down. Let's do the same trick here with the friction, that we just prevent twisting. I had a cheap 12-volt Chinese power supply that was powering my home monitors. It burned and almost caused fire. Yeah, that's one thing why I, even while I was still going for the super cheap version of this machine, I kind of did a preliminary bill of materials, and I still had like a proper PSU in there, because I feel like you can do a lot of damage with cheap PSUs. It's not worth, like, even if you want to build like a super cheap printer, right, it's just not worth like cheaping out like on 15-20 euros for like a proper power supply and risk like a fire or something. But like, this is the power supply I'm gonna use. That's the Meanwell LRS 150-24. So that's technically also what the Visor uses. This is like 20 euros. Like, it's not expensive. And I got this from like a proper electronics store, so not Amazon or AliExpress, and it was like 20 euros. It's not expensive to just get a good power supply. But it's just my opinion on that. But yeah, technically, like, you can cheap out on the power supply. Like, there are cheap options. Like, you could also use an old PC power supply if you go for 12 volts. I don't think that's like a dangerous option to like recycle something in a certain sense, or like upcycle something. Just kind of like somewhat put it in the center. But yeah, so for example, like, you can buy 200-watt power supplies on AliExpress for 4 euros, 5 euros. Like, if you look for LED power supplies, like, you get like super cheap stuff, and this can't be good. Like, if you get like a 200-watt power supply for like less than I don't know, a coffee, basically, then they can't be good. Haven't seen the build since we were discussing flange bearings instead of printed version. You've certainly made good progress. Yeah, I mean, the flange bearings are now in there. That's completely redesigned. It's kind of like a hard. Yep. Here you go. So these are like standard flange bearings now. So I redesigned the parts to just accept like the flange bearings instead of like the printed ones. Which the parts look the same, but I had to reprint the entire like gantry basically because of it, because all the parts are in some contact with the bearings, or like the bearing stacks. And I also beefed the parts up a bit. So if you compare it with the earlier versions, like this like cutout here is a bit smaller. Everything's a bit thicker and beefier. But yeah, like, it works. Like, we have motors in here, and like last stream we had the main board connected to that, and we can move that, and relatively fast actually. So it all works. Now it's just like we need to figure out the. Okay, this does not work. I will have to hold this here. But yeah, we already see like there's a bit of. I mean, it's quite heavy. NGMI. I don't know what NGMI means. Yeah, we still have a bit of twist. I mean, if I move it by hand, it's fine, but I feel like I'm subconsciously supporting it, or like not subconsciously, but like I have to make sure this doesn't twist. If I just pull it up, it twists and then it starts binding on the front. So I have to make sure this does not twist. Yeah, so basically now you see if I have this twisting, I'm not going to make it. Yeah. You are correct, not going to make it. Yeah, like if it twists, like it becomes hard to push, and I feel like that the balls are not freely moving, like there's like janky movement. But if I prevent that from twisting, it works perfectly fine. When you're using your hand, you're putting by 2 points. Yeah, exactly. Like I'm pushing up here, but I'm pushing up and I'm pushing down. I'm pushing on those 2 points. And now it's smooth. But the belt basically only does that. And then it's not smooth. But then I think, I mean, technically later the belt is doing the same, right? Because the belt would go around on the bottom motor and then would reattach here. You can't really see that, I'm sorry. Let me just... So the belt would do this later, right? Then the question is that not technically the same that I do with my finger? Everything is crooked. Don't look at that. It needs stiffness, yeah. The question is if we prevent the twisting in the front, because at the moment, like I mean, it's just a test setup, right? Like nothing of this is like final. It's just like for me to figure out how that would work. At the moment, we only have one connection here. If you would have two, this would not rotate. The question is then, even if this would not rotate, would that be enough that when I pull basically on one point, if this would not rotate, if I pull on one point, would those start binding up? Because I mean, they're binding up, right? Because we're pushing them in this like angle basically. Like we're pushing them out of square more or less. But then the question is like, doesn't the binding more, the twisting kind of prevent it already? Like, would it be, if this would not rotate, would the binding issue be worse? It's not the same. The belt is only pulling up. It does not push down. It should be enough. The second upper rod will do the pushing like you did with your hand. Yeah, I think if we have two, I mean, if you want to try that, right, I would need to print one more of these parts, because then basically what we can do is like we can just add another one on each side, connect that, like we just add like another rod here, and just thinking of ways we can quickly MacGyver that together. Yeah, I think we need to print some parts for that. The two rods together with tape. Yeah, but even if I put those two rods together, I mean, I can also use like cable ties, zip ties, right? Yeah, I think I have it here. Let's quickly remove the bat. Wait, not this one. I think what I can do is I can use I just put this here on top. I use zip ties left and right to pull it together. And then we just need to use some other connection method for those two rods with that. Okay, let's quickly try that. You need to connect it to the rear legs and use 2 more rails and to join front and back legs. Yeah, so basically the backup plan, Wes, is to add a 3rd rail in the back, not rail, a 3rd rod in the back. But my ideal setup would be to have only 2 rods to prevent binding. Because I already forgot who, but like somebody in chat already pointed out that the Rook had initially 4 rods basically for that. The same I would then have. And they ran into problems with binding. So ideally we prevent that. Or like not repeat the same mistakes. But it's actually first try that. So let's put the rod below. And then let's just use zip ties. I had zip ties in my hand before. Where did I put them? Let's just I feel still it won't be stiff enough. The leverage over the distance is huge in relative terms. Yeah, that's like also my concern. I mean, like the backup plan basically is adding a rod here. That's also why I have 1 more of these. So basically, this would be the backup setup. Because then basically you have the support on the back. And the belt would still be here towards the back. If I can get away without that rod though, I would prefer that. The things with this setup, we also don't have a twisting issue anymore because now it's supported in the back. The force bearing can be held in with springs so it can move, but still support the bed depending on the spring stiffness used. That's actually a very good idea. I mean, even if with the 3rd rod, I'm kind of concerned with binding. But even there, right, like we can, this does not there's no need for this to be super rigid here, right? So technically we can encase the bearing on top and bottom. Technically this is enough. Like if the rod goes through, and we just grab it here, this is already enough, right? There's no need to enclose the bearing around. Like it just needs to push. Technically, yeah, like we just said, no, we have to kind of fold it up above and below, but this doesn't have to be restrained in a lot of ways. And this should also help a lot already with binding, that we just like let the bearings align themselves. But then it's like, yeah, let's see how it plays out. Let me first get this rod in place and see what that does. Okay, not sure if the cable ties are tight enough. So my hands are a bit oily from the grease of the bearings. Not really helpful. Okay. So this is now kind of okay. I don't think it's strong enough. Let's just add some tape. You have something to wedge the bed to this new rod? That's the second problem I have to fix, step by step. Let's first get this in place. Why not rotate the bed so that the two bearings are at the back? So you're pulling up the strongest section. Yes, that also would help. Wait, let me quickly finish this. 1 second. Oh. That would also help to have the belt basically pull here, more or less, than just on the back. The reason is that I don't have suitable rods in the back. So basically, if we kind of keep this rough setup, right, that we have 2 rods here and 2 rods here. Here we have the motors that are kind of interfering a bit. So I would need to have like a separate rod here, which you can do, but then like the frame just becomes a bit more complicated. So my ideal setup was basically exactly what you're building now, like 2 rods in front and 1 rod in the back. If we get this to work, then this would be like my ideal setup. Optically, I think it's nice, or like optically, visually it's nice. Wait, let me actually quickly push this up a bit. Everything. Oh. Visually, it's nice. Okay. Maybe not. Visually, it's nice, and it's like simple, and simple kind of wins for me in this build. Rotate the printer so the XY motors are at the front. Technically, yes. Then I would have to redesign a couple of things, right? Because like if you would say this one is now the front of the printer, for example, you have a lot of stuff here. So then we would need to redesign the entire gantry. But yeah, technically you can have the motors in front. That would actually be a fun concept, right? Like instead of the front idlers, you just have the motors here. Left and right the motor, because then you don't need the front idler and you don't need the motor bay in the back at all. Okay, let's quickly try to finish up one project at a time. So now we need to prevent rotation here with the second rod. Let me see, how can we do that? I think the easiest is to just add this part. Add this part on the rod on the bottom. Then those two like butt up against each other. And then they can't rotate. Let's quickly try that. That might already be enough. Some printers are that way for ease of belt tensioning. Yeah, I mean, it removes a bit of complexity. I feel like this would have been a design decision we would have needed to take. No, I don't get it. That is a design decision we should have taken like earlier in the project. Let's see if I can. Okay, I have to remove the cable tie. Here we go. Yeah, but this should prevent the rotation. Pretty well. I think like if this setup doesn't work, my next choice would be the third in the back. The third rod in the back. I mean, the other option would also be to just have the Z motor in front, but then basically you have the belt going in the front, which is a bit annoying, I think. Because you kind of want to access the bed as well, and then you always have to like reach around the belt. I'm already annoyed that we now added this cross beam here, because also like kind of obstructs access to the bed. Okay, let's see if this helps our rotation. Yeah, it's definitely stiffer. Still rotates, but now like the bottom rotates with it. Turned upside down next to that movement. Yes, that would also be a solution. That would also be a solution. A fun one. 24/7 Printing did that recently, right? He turned his trident upside down. What's 24/7 Printing? I think so. He just flipped the trident on its head. Okay, let's really see what this is doing. I lost the screw. Ah, I see. I found the screw. Okay. Hey. Constantly dropping those nuts. Let's see if this is stiff enough. I mean, technically we should have already started printing like just like a fourth of those bearing housings. Let's maybe quickly do that. Yeah. Now basically just rotating here. So we definitely need not sure why I didn't think of that. To wedge the bed if you place the new rod above instead of below it. Not quite sure if I can follow you. Evgeny? Evgeny? No. So you want to have the rod above. I mean, the problem at the moment is not that this construction in the middle isn't stable, like this is quite okay. It's just like that the rod here is not stable. Let's just do the following. Let's quickly print like one more of these parts. Then we can just add 2 on each side. And then we can like properly secure the rod on each side. Yes, I zip tied it below. But I also added this here, right? So this kind of like, if I now push up here, this can't rotate anymore. Like it rotates now because the rod isn't secure on the side. But this is not this is not moving. Basically the entire rod on the bottom is moving. But this black thing doesn't interact with the bed. Not holding the bed. But I don't think it has to. Maybe I'm missing something, but the bed is secured here and here, right? So the bed is secured here and here. And maybe flip it over. The bed is secured on those 3 points here. 1, 2, 3. So it's secured on this rod and the top rod. And this rod here is with those parts coupled to that rod. New rod moving around is the problem. You should print those new parts. Yeah, exactly. So if I prevent, because like you see it here, like if I now push this, you see the rod here, like it's a bit hard to show, sorry. Like this now moves here. I mean, I could also try to zip tie it to that rod to prevent it from. Let's quickly try that and then we print the part. If we add like zip ties around here, we'll make it a bit harder to move. Maybe that prevents it. There's some oil on the rod because I greased the bearings. The bearings are like oiling the rod a bit. Oh, okay, no. Now it's really hard to move. It's still twisting. And now the problem is here in the middle. But also this we can technically fix. We can use really long screws to connect those parts together here. Middle part in addition to the two side parts if you're printing stuff. Yeah, the problem is the middle part we need to design. I don't have that ready. Okay, let's quickly start the side part, just as it's printing. Let's also preheat the printer. But I think the side part, the middle part, we can combine those two parts together with the long screw. Okay, let's print the part and then let's screw them together. I mean, step by step getting there. But yeah, if I would have better parts, then this would be easier. Do some leverage calculations. Even 100 gram of force is likely to be 5 millimeters of movement over the distance. And that inertia of Z lift you're using it might save you time now if you can assess it. You mean 100 grams of force here in the back? Oh wait, the size isn't here. Orca. Yeah. I mean, it has quite a long lever here. That is absolutely true. Like, yeah. Let's quickly try that because I have no clue how to do leverage calculations. Let's print this part for the front. Then we can combine that. Let's screw the block together in the center. And then we have a twist-free setup. If we then still have the issue with the twist-free setup when we pull on the belt, then I think this setup doesn't work and we need to add a third rod in the back. Let me quickly see. 1 second, I need to find where I just really hope I saved that. Ah, here. Bearing belt clamp. I almost feared I didn't save that. Let me quickly export that. Second. Okay, here we are in Orca. So these are 2 parts. And there's a fun bug in Orca for some reason. Every time I restart Orca, it sets the max volumetric speed to 2. Super annoying. So let's just slice and print that quickly. And then this is off, and we can do other things. It shouldn't take long. 20 minutes, yeah. So preheat will be 10 minutes or a half hour. We have the part. You can calculate rotational force, or you can ask ChatGPT. You can click on torque equation on the calculator website. Also might be worth running all steel tubing on the bed for increased stiffness. Yeah, definitely. I will, like all the hollow parts, I will replace for sure. At least with the solid aluminium. Like this is already way stiffer than the hollow one. Or upgauge aluminum. Yeah, like I tried to stick with the 8mm ones for now. But yeah, the solid core will already do, like, because this is quite stiff, especially if you have like relatively short runs, right? Let's see. Okay. Then let's prepare that. Well, this is printing. Let's prepare everything. Oh, there's still like stuff on the print pad. Maybe not so good. So we need to connect those two. And add linear, one linear bearing on each side. And then we also don't need this setup here anymore, because then this is properly connected. So but yeah, like if we flip it around, like it will already be much better, right? If we push here, it's way better. I mean, also every printer has that setup, right? Where the 2 rods are in the back, not in the front. I think before I do 2 in the back, I'd rather do 2 in front and 1 in the back, because the 2 in the front we have anyways. There's not really like a way around that. It's better with the bed has nothing on it. Once you put weight on it, the torque will start being a problem. You mean like if I put a weight on this end, basically? Yeah, that's for sure. That is for sure. I think the end result of all this will be we will have 3 rods. I'm fairly certain of that. I'm just trying to delay the inevitable. Oh, yeah. We don't need those. I need to be careful. Sometimes YouTube Music enables autoplay. And then starts like playing random music. And before you know it, you're playing copyright music. Now we should be fine. Other option, you could link all the Z positions with the bells so that they're pulled together. Yeah, it's also something I thought about. I mean, I don't want to add 3 motors. So it would need to be some mechanical link. But I'm not quite sure how I would design a mechanical link for that, to be honest. Not something I did before. I'm pretty sure, like, if we add a 3rd rod, like, problem should be solved, right? Or am I misunderstanding physics here? Like, if I have a 3rd rod in the center back, we should not have any issues. With 3 mods, you could do tri-gantry leveling in Clipper, which could be quite good for automated bed leveling. Yeah, I mean, yeah, but it kind of defeats the purpose of having like a low-cost machine. But I would totally be up for like tri-gantry bed leveling. That would be quite a cool thing to have. You are misunderstanding physics, yet you will have issues. So what's the issue if I have 3 rods? It's still like the like basically I gain stiffness, right? But then like I still have lever forces because I pull on one side of the bed. So my idea is basically just to use like long screws and like we have to quickly screw that, but I only do 2. Three rods doesn't work either. So what would then be the solution? The bed frame has to be super stiff, otherwise you will get binding with 3-2. Yeah. Figure out how to do that here. I think we have to do it this way. It's a bit iffy because I have 2 heat inserts here. You need to make sure the bed frame has to be super stiff, otherwise it will be binding. 2, you need to make sure the bed is hard perpendicular to the back plane. Then you can pull by a single point at the front. That would work. Correct me if I'm wrong, Wes. Evgeny, sorry. Hard perpendicular would mean in this case, right, that like if we prevent the twisting setup here, like if this would be like really stiff and this is really stiff, then we could pull at a single point, right? It's just like as soon as it starts to twist, we are out. That's basically like what you're saying. Stiffness comes with section, but if you're not creative about how you add the section, you will limit your Z travel lot. Yeah, exactly. That's the thing. If I now add, for example, like a second one here, like we already double the height in a certain sense. The left-hand side is fine, but there's also no weight on it. If you lift the left-hand side, watch how much you can move it in Z before the other side moves. I think that's pretty instantaneous, to be honest. There's a little tiny bit of wobble. Like if I have it, I'm not sure if you can see that. maybe millimeter. Like if I push it up a millimeter here, it goes down a tiny bit there. So there's definitely some flex there. I mean, if we add like more, this gets definitely better. Prevent twisting, it would work up to a point, depending weight. Yeah, exactly. The weight is the part here. Now at a small weight, it will show you. Where should I add the weight? Wait, let me quickly add the screw here in the center just to finish this off. Let me quickly do this. And then already put this through here. I'm not connecting it, just maybe that's already the weight. Just give on the opposite side where you lift. Okay. Okay, so this should now be connected. We just have to add some spacer here because the rod is too high up. But this should give us the thing. Okay, so now basically you want me to push up on one side. And basically add some weight here. Yeah. I mean, I'm just slightly pushing down here and it's like binding up. But this is not super stiff. Yeah, I actually have electrical screwdriver, like a small one, like but I lended to a friend this week. I had it back here for the longest time. But as always, like you don't need it for a long time. You know, when you need, you don't have it. Oof. Yeah, I'm just wondering, like, this will be stiffer with like more bearings. Let's do the following. Let's add 2 bearings on each side. The first layer didn't print well. Yeah, that did not work. Let's try this again. Yeah, that's V0. That's what I use for the prototyping parts because it's like quick to like print something on stream. When you add the additional bearing blocks, you need to be able to compare how much it has helped. Yeah. No, it's ABS. All those parts are ABS. The turquoise ones are Polymaker ABS, and the black one is Form Futura ABS. It's all ABS. I dropped the PLA at some point because yeah, just wasn't strong enough. I think the problem was that I used matte PLA, and I kind of had like a learning experience there. Matte PLA behaves very much different from normal PLA. It's much weaker in terms of layer adhesion. I think I need to clean the bed. It does not print well. Let's quickly do this again. Let me quickly wipe down the print bed. Let me quickly grab some IPA. I'm right back. 1 second. Okay. I've got to go. Catch you later. Thanks, Wes, for tuning in and all the tips. Let's quickly print this again. I'll just set the speed as well to 40% for the first layer. Should be fine. I'll just I quickly wiped it down with IPA. Let's hope this fixes the problem. Yeah, ABS is more proper plastic for this application. Yeah, for sure. The idea with using PLA in the beginning was that it's easier to print. So, I mean, my initial goal here was like to create like a very accessible machine that's cheap to build. Kind of failed on that, I think. So yeah, it was just like trying to use PLA basically just because of that reason. It was just much easier to print PLA than ABS. Let's see. Man, I did not expect this to be that difficult. I think we can also leave out those rods for now. We would have only needed them if we added the rod in the back. Okay. Get rid of this. Get rid of that. Here we need to loosen screws still. You need a first thing for your zero. If the left first line with a piece attached. Oh, okay. Like I don't know why it refuses to print right now. Let's see. This should work. I printed just before the stream and had no problems with the first layers whatsoever. Let's see. But yeah, the perch line is not perfect right now. Weird. Yeah, like you see like you see my cursor? Yeah, like the little point here, it's like for the perch line. Let's see. Okay. Let's just flip this over and then we can add 2 bearings. one more. Maybe we can also use the zip tie now again. If we zip tie it to the bearing instead of the rod. Where did I put the zip ties now? Here. I don't think there's a decontaminator mod for V0. The problem is a bit that like the print area is just so small that if you add anything to it, like you just lose precious print volume. Same with like clicky or something like that. Like anything that loses your build volume is just like not really an option. You would need to use a servo or something to like move the brush in, and then you can like use a brush or something to decontaminate. Oh. The bearing jumped up. Now I have it like zip tied to the rod again. Let me try it again. I have a V2 350, plenty of space there. Yeah. I'm also planning on building a V2 later this year. Let's see if it works out. But I want to build a 300. Yeah, that zip tie broke. Third attempt. Yeah, let's not do it too much. Whoop. Let's flip this over. Okay, so now basically Wes said, yeah, but now I also need to add this back here, otherwise that's not really a good comparison. Let's quickly also make sure to tighten this. I think it's fine if we only tighten 2 of the 4 screws there. It's kind of like overkill either way. Okay, so basically I don't think it's much stiffer in this direction, but we only use the zip ties now here. So there's not a lot gained from this exercise. The question would be, I mean, I'm pushing now only with one finger. And it kind of seems okay. The bottom rod doesn't move at all anymore. So if I can show it here, the bottom rod doesn't move at all anymore. Now that it's like zip tied to the bearings. There's still like flex, but basically I can move it up, and the moment it reaches the maximum deflection, basically, like it's fine. So if this is good or bad. Let's add a bad and see what that does. Oh wait, let me set the speed back to 100%. That would help. Let's add our like preliminary spacers back. One. It might not move, but it rotates. What do you mean by it might not move but rotate? Like it's still like it's a bit like there's a bit of rotation still, but there's a limit to the rotation. And when it reaches the limit of the rotation, it starts moving fine. I think if we add the bed now, this should also make it a bit more stiffer, or a bit stiffer. Let's see if that helps. It's funny, like I did not expect this to be such a big problem. Good. I'm missing my two bearings that I use as spacer. I have no clue where I put them. Let's see. Oh, it's a zip tie graveyard here. Let me quickly get rid of those. I have no clue where the bearings are. Okay, let's do it without bearings. Should be fine. The rod moves, but rotates on its own axis. That's still movement. Oh, you mean the top rod? Yeah, that might be. Yeah, so basically now, sorry, it's like really awkward to show. So if I move it here, like the rod doesn't rotate. I think it's mostly the connectors here. Like I think it's this part here. Because like if you see the back part doesn't move at all, it's only like the front section basically. So I think it's just like that this isn't tight enough connected here. Which I guess is something we can fix. Let's see. Still. But the things it moves fine. Like it flexes up and then it moves okay. Which of course is not okay, but so if we make this stiffer, like if we make this connection here stiffer, I mean the bottom rod still moves. It's way less, but it definitely moves. You see here? I guess I move it up, like it moves back. Yeah, I definitely have like the flex needs to be gone. But the thing is, let me quickly check that. Yeah, my microphone is still working. Like last time when I had to switch my AirPod microphone went out. So basically, if I have proper printed parts here and I get the flex out, the question is still like, would this be okay? If there's no flex here, will this be an issue? I mean, let's just... This is like the worst position, right, for weight. Now the flex gets worse. silicone, so it shouldn't slip. Yeah. Okay, this doesn't work. Like, it's flexing now so much that like... So weight is really like a problem here, obviously. You need a torque calculation. Yeah. How do I do that? Let's see. Yeah, I would have Googled also torque calculator. Okay, so the distance we are looking at would be something around 20 centimeters, right? Like the print bed is like 18. Let's add some give and take. So let's say just 0.2 meters. The force yeah, the force would be how heavy would it be? The distance between the back bearings and front bed. Yeah, exactly. Like it should be around 20 centimeters, give or take like a centimeter, right? Because like the bed is 18 centimeters in depth. So let's just say like we add 1 centimeter in the front and 1 centimeter in the back, so 20 should be fine. 1 kilogram is 9.81 newtons. Yeah, that's the one thing I took away from my physics lessons. I don't know. So the question is just like how heavy is this, right? Like the let's just say the bed assembly here is, I don't know, maybe in total, let's just say 500 grams. I think it's less, but let's just say 500 because there's a build plate. And then let's say like the max print weight is a kilogram, so 1.5. So that would be 1.5 times 198, so it's like 15-ish. So we have 3 Newton meters of torque resulting from that. Then the question is, what does this number tell me now? Because that's the part I don't know. I think 3 is a bit, like it's not nothing. But it basically just comes to like this connection here in front needs to withstand 3 Newton meters of force, basically. And the bearings, of course. I mean, what we could also do, if you want to remove the flex, right? We can also add a connection like this here. Oh, sorry. We can also add something like this. If we have like a better printed part here in front, we can add something like this, just like to make this much stiffer. I mean, ideally, let's say like we have it like this here and the belt connects here in the back. I think it comes down to making it stiff. I mean, the other option is just like looking at this here. I said like this rod, like the problem is like I don't want to reconstruct the gantry a lot right now, because if I have to rework the gantry again, we're kind of like making a setback. Newton meters tell you how hard you should be pushing in order to move it up and down. Pulling with the belt and pushing with stiffness of the rods. Does that go on here? No. The rod here is a bit too, like I'm trying to push the bearing on this rod here in the back, but this is a bit too like, because they are hardware store parts, they are like a bit too thick for the linear bearings. But basically, like my thinking is right now, how much space is between the rod and the motor? Like if you would want to move the rods from the front to the back, like we would have way less problems. Oh, here are my my bearings. Right, that's like understanding that I have is like if you move the rods from the front to the back, like we have less problems because we are pulling where we are also having the bearing. So, and we can also just add something here. And we can prototype that because I have those T-clamps here and we have those shorter rods. So if we add like one connection, if we add one connection on the bottom, we can like mount this in the middle and we can move the parts to the back. Then we can also try this in the back. You have slightly less weight because the torque equation you need to calculate the weight that is x meters away and the bearing are 0 meters away. Yeah, exactly. The more weight we have basically allocated on this plane here, basically, or on this axis, the less problems we will have. I mean, it's also like the V0, for example, the Rook as well, right? They all have the vertical bearings and then the driving thing in the middle. Like for the V0, it's a screw. For the Rook, it's a belt. Yeah. This is done in like 2 minutes. So let's quickly try to. I think we don't get this stiffer. Like there's still so much flex also here in this middle part. I wonder where the flex is coming from. If I push, I mean the center part rotates, of course. Because the belt, like the ends of the rods don't move at all. So all the flex we see in this part needs to be like in the center of the rods. Yeah, I mean like now the ends move. Okay, let's how to do this? Let's put it on the side. Let's add something here. Let's quickly loosen that. Yeah, but it's definitely a bigger challenge than I expected. Oh. Oh wait. this way. So let's put this on here and quickly those two screws. We have to loosen the center part here because this needs to be a bit more spaced apart. No, yeah. We have to take it all apart. Let's see. Okay, that's one. Number two. And number three. Come off. Going back to the electric screwdriver. Okay. Okay, now put this together. And then we need to kind of space this middle part here in a way to make this work. Sure if our screws are then long enough for that. I don't think so. Yeah, before I tighten it, we need to add it on the other side, because now, like, I just... pull the rods in not so good ways, but I think that might work then. Okay, last layers. Say 25 seconds. And then we just like rip it off the bat. You should think about redesigning it. Yeah, like those parts are for today. I'm after today, I'll just trash them. Like nothing of this will be in the final printer, right? This is just for me to try out the bat. ABS doesn't love to be ripped off the bat. Yeah, but for today. for today, we will do that. It's really just like none of those parts are like final, right? It's just like the only purpose is to figure out how to make this work, and then I will like design proper parts. Let me actually keep the printer on and the bed heated in case we have to print something else. Then it's already preheated. Okay. We need 2 heated inserts here. Yes, that is most likely why my first layers are bad. It's actually a good idea. But the nice thing about this build plate, let me cool down for like a hot second. You actually see where I touched it, like it decolors. And there's some random filament stuck there. Just quickly bathe that in oil, and not in oil, in. Here you go. Freshly cleaned, de-oiled, and ready for next round. Okay, one. And number 2. Okay. Now we quickly grab 2 screws for that. Let's make sure that they have the same width, but yeah, it's like nothing is really square, but not very surprising. The way I bolt this all together in like most random order. Okay, let's see if we can connect that. Yeah, I think now the screws being too short comes into play. Like there's just like not enough reach. Yeah, that's not good. Like we need some spacer here in the center. Let's space that properly. Not sure if the middle section will be enough to clamp the rods together in such a way they don't twist. Yeah, me neither. I don't think this works. So most likely we're not getting around designing proper parts for this. Yeah, I don't think we get around designing proper parts for this. Yeah, that's kind of like what we would need, right? Ah, sorry, it's like completely unfocused. So that we need some space here in the middle. That's actually like a perfect height. But then the screw we need would be like 50 millimeters. And I don't think I have 50 millimeter M3 screws. Oh, what we can do though, we can do it in 2 steps. Wait. I only have one of those spacer parts. Let me see. Do I have something laying around we can use as spacer? Like this is such a MacGyver hack job. I know where I have them. Give me 1 second. I'm right back. Here we go. I just remembered where this comes from. This is from the Ender 3 parts. It's okay. So here's my plan. Like we add the spacer. Just need to like back out the screws. Ideally there would not be heated inserts in the top part, of course. I mean, let's remove them. What's the deal? Let's remove them. But yeah, I think the result we see here is that we cannot use the rods in the front. That would be like my takeaway. Like the setup like that I had in mind with the rods in front, it doesn't work at all. It's just an absolute no-go. Do you have acetone to glue the ABS piece together? No, I don't have acetone. But that would be also a good idea. Just quickly get the heatsink insert out in those 2 corners. So I think, yeah, we just have to move 2 rods to the back. Two rods to the back, and then use the belt between the 2 rods. I think that's the best shot we have. And then if that doesn't help, or like if that's not enough, we still have to add more rods. But then like we will get into the binding issues. Okay, so let's get shorter screws. I think 25 most likely will be enough. So we add this and that, so there's no screw anymore. No, 25 is not enough. We need a bit more. Go for 30. And then we can also put the rod in between the two, not on top. That also might help. Then we need the spacers. Ha, still not long enough. We need 35. Step by step getting there. Yeah, exactly. 35 is fine. Now we can put this together. I mean, the other option is, right, like to not have the rods like on the section here, like just have printed parts. I'm not sure if this makes it stiffer, potentially. Okay, so this is now connected. Sorry, like you don't see anything. So we basically have now the bottom part here. Oh, which I put in the wrong orientation. This needs to be like this, of course. Oh god. And back. Printed parts with rods inside them. Yeah, that's actually also a good idea. Because if you have like printed parts like quite long, that just prevent any twisting motion. You might stiffen everything up a lot, right? And it's just like, I'm not sure if it's like worth the hassle in a certain sense. Because the idea with the bearing in the front, right, was to have like a simpler setup in a certain sense. And if you then start like having big printed parts to make everything work, like maybe it's just like not worth it. Going back to maybe we just add the rod in the back and eat like the things I don't want to buy like have extra rods, but maybe that's just like what we have to do. Okay, now we can dock this together. Technically, we now even add a second one. But I don't have the same construction again for here. So it's not adding a lot. But technically we can have two. Oh wait, that's the wrong one. We have to do it opposite. Here we go. I mean, it moves. Let's add one connection here. Okay. Yeah, it's stiffer, but it's still twisting. But I really wonder, like, if we would add like an extra rod here on the bottom and somehow connect those two. Nope. If that would help. Just having like the double here. Just like I don't have anything, like technically we can do the same solution we have on front on the back here. Right, this is kind of where the belt would be. Yeah, let's do that. Let's last attempt. The two rods at the back already look more rigid, but space between the top and bottom bearing is still a problem. Those spaces will allow flex. You mean this gap here? That definitely will be gone. Like if we design proper parts for that, like there won't be any space. It's also like the more space you have here, right? Like the bigger the lever is the wrong word, but like the more rigid it should be, technically. Agree, when printer is moving, it will probably bind. It should be one printed part. Yeah, like again, like this is only like a testing setup. I just try to verify the concept. This is not final parts. Like these are just like parts I made to kind of like Lego something together. Just like to try different setups, but this is not the parts I will use later on. Like there will be like proper designed parts for that. Yes, the more space you remove the side-to-side movement, but you tried before. Yeah, exactly, with West's suggestion, but it shouldn't have a space, it should be rigid. Yeah, they need to be completely rigidly connected. Okay, so I'm just building like another one of this like deck solution. We have the front, so we basically just have like 2 rods here and 2 rods here. But yeah, so if let's do this as a last attempt. If we would then say this is a feasible way, like it's worth pursuing, I would design proper parts for the setup. But then I think it's not a good idea to have this as the only approach. Like we should still have a backup solution. which I think at the moment, Evgeny, maybe you agree, but I think that the best solution would still be like to have the rods here on the back, left, right, and then have the front floating, but then basically belt between the rods. Let me get this out. The best solution will be 3 motors, yeah, but sometimes you have to settle for the second best, because 3 motors will not happen. Especially like 3 independently driven motors, absolutely no. It's just like because then you need a separate board. 3 motors also not really. Like, wait, let me search for screws. Technically, you can drive 3 motors with the same stepper driver, right? So one setup would be that we have 3 motors that are driven from the same stepper. If you have 3 rods, yeah, that's one thing. But then I need 3 like screws. Like it just adds. Wait, how did it do that? Oh yeah, that's exactly how I do it. It just goes through here. Then I need to quickly grab more of those spacers. Let me quickly grab those spacer parts. 1 second. Rod spot belts, and yeah, exactly. But then the problem is basically you need to have, it's a separate like item on the BOM. The reason why I wanted to go with rod initially is that you already have to buy belts because of the XY axis, right? So belts are already on the BOM. Whereas if I now start adding like a new item on the like the lead screws, if I add lead screws to the build, then it's something extra you have to buy, and that's exactly what I'm trying to prevent. Because like, well, I kind of said like I don't want to hit this like ridiculously low 100 euro price point anymore. I still try to keep it relatively low. You can print a prototyping. Not sure how expensive they are. What would be the length you need? Yeah, like the price is not technically the problem. I actually have 2 laying around. I forgot the spacer. I have 2 laying around actually. It's not the thing. It's more. It feels like a more complex setup having 3. I forgot to add the little spacer. Also not really focusing on what I'm doing, right? Yeah, it's not only lead screw, right? Then you need bearings for the lead screw. It should do is like that. So it adds quite a bit of complexity. But yeah, like I agree, like having it like driven on 3 points is the best solution. There is no argument to be had. I mean, what would be worth exploring? Let me quickly put this together. We tried, and then let's check what, for example, like Ender 5 is doing, because Ender 5 I think has a single lead screw. Pretty sure the Ender 5 only has one lead screw. So instead of like reinventing the wheel, let's just check like what printers with a similar layout that are not the 2.4 or Trident, what they are doing. Okay, let's see. So this is kind of like the point where we would attach. Well, this is already way better. Like there's still flex. But way less than before. But yeah, now you also see like, I'm just trying to like show you the rod. Like if you pay attention to the rod, I think. So I'm just holding it down. Do you see like how the rod is really like flexing? Like the endpoint stays the same, but like the middle section just bends. These hollow rods are not rich enough. Yeah, that's exactly what I was thinking. Let me quickly swap out the hollow rod on top. I mean, this is like a quick fix we can do. This should be relatively easy to quickly swap this out. And again, like it doesn't need to be perfect right now. Like I just want to be at a state where I say like it's worth pursuing. Now I fear we have to take this apart quite a bit here, because I added the electrical tape. Yeah. Oh, we kind of have to take this apart. Have to take those apart, of course. Ah, here we go. Okay. It's way too long and not cut to length, but this is solid. Oh wait, I actually have this one is solid and steel. Solid and steel. So both of them, you see like they're both like chrome plated. They're both solid steel. The only problem is not like these ones. These are still hollow. But actually we can also swap out one of those. Let's swap the bottom one out, also for like a solid steel one. So this one goes out, and then we swap this one in. It's a tad too short, but we can adjust it, of course, a bit. Here we go. Okay, and now we have to that. Even the middle hollow ones don't need to be changed. They have flex forces on them. You mean this one here? Like these? Yeah, you're right. Like they would just bend. So like now it's better. more stiff can't hurt. Okay, we are getting there. So now if you look here along the rods, like if I bend this, like there's still like a bit of movement, but it's way better. Now that the thing is like if this would be like one block and this would be one block, because also here like you don't see it. No, you don't really see it, but if I put my finger here on both of them, I feel like the top block, how the top block and the bottom block, they move a bit. Okay, let's do... Oh no, I forgot to put those on. This reminds me, once upon a time I could build a CNC machine that cuts metal with 8mm rods. I was wrong. Yeah, that's me. We all have to learn. Okay, I have to quickly loosen that again to slide on these parts. But yeah, it's kind of like the idea of the series, right? Like I'm not an engineer. I never designed a printer. It's just step by step I'm learning. And hopefully it's fun for people watching me fail. Watching me fail and then improve. And yeah, it's fun anyways. Yeah, that's the goal. I think it's a cool project. And this doesn't need to be like world's fastest printer or anything. Like if I get like a decent printer out of that, I think it's a really cool experience. Okay, this is one side. Quickly do it on the other side as well. But yeah, I didn't expect the bed to be such a challenge, to be honest. Like the gantry was for me like the biggest part, where like I was kind of like in doubt whether I can actually manage to build that. But the gantry is now working relatively fine. And I did not expect the bed to be such a pain. I mean, I'm not really having like an ideal setup. I don't know why I'm doing this like not easier. So let's quickly squeeze that in here. Okay. Let's try to throw on the bat and see what that does. Hey there, Jonas. This nut doesn't want to. Here you go. This does not want to go on at all. Wait, oh, we need to add our very professional spacers. It's just long enough here. Need some distraction. I'm writing reflection code and my head is told. Oh, reflection. Oh, you mean like software reflection, like Java reflection or something like that. That is literally the worst. I hope I can. Oh, Go reflection. Okay, I never use Go, so I can't count on that. But if it's anything like Java, then it's not fun. I actually. Go on. A couple of months ago, I had to write a compiler plugin for Kotlin. That was horrible. So I can imagine this is like a similar experience. How can I get this nut here? Now what I'm doing is kind of simple. Yeah, okay. I wish you all the best. But I feel like this is slowly getting to a point where this is like a usable setup. Screw the tightness, roughly. Cool. Okay, let's try this. So if I lift up here, we have success. Like it flexes initially. Like if I hold it here, like you see it flexes up, but this is fine. Like this will just be a bit under tension from the belt. But this moves fine. Then the question, what happens if we add weight? It's still fine. Evgeny, I think we have a success here. Like this is not a kilogram, but it's relatively heavy. Like definitely half a kilogram. It's a glass bottle. Oh, now it's like touching the front rod, but let's try what happens when we use a belt. I just have to support this here on top. Yeah, this is like quite heavy for me to to hold, but well, it is heavy. It is heavy. I mean, you have quite the lever, right? But it would be the same. No, it would not be the same. Like if I would pull here. Yeah, this is of course much easier on this side. Backplane still needs to be more rigid. You'll need to design some parts of it. Yeah, you mean this side here, right? Yeah, definitely. Like I have to design parts for that, 100%. 100%. I mean, this needs to be one block, of course. This needs to be one block. And yeah, that's clear. The question I have is just, wait, let me also like, destroying the belt here. So if I hold this up here, let me do the following quickly. I have this like stubby piece here. Let's replace this with something that can span the full width. And then let's find some other weight. Okay, let's just use this rod here. Wait, you have no clue what I'm doing. So basically my idea is just like to have something from front to back. Because now what we can do is we can really put the belt around that. Ideally we would have like a bearing here. Will the print head not interfere? Well, this is just temporary. Like the entire goal today, Jonas, it's just like to figure out if the concept I have for the print bed works, and I'm not sure still. Because basically I have the two rods on front where it rides on. And I want to pull on the back with the belt, and it's kind of like a funky setup, and it's not really ideal. So this is all just to see how this works. Try the belt at the back, but this is basically how far back it will be, right? Like this is the position it will have later on. Like if I move it back further, like yes, it becomes more hard because the lever grows. No, back it. Oh, you mean, yeah, I call this front. You call it back. No, it will be like much easier. But you're right, we can quickly try that. I have to undo the bed again. Because what we can try then basically is how would it be if I reverse the entire setup? I can already tell you where I won't put any screws in the final part. Yeah, I have to completely undo it. No way around that. So let's do the following. Let's loosen that here. And loosen it here, and then I think I can just push the rod through, and then we have like a bit of rod sticking out in the front as well. Hopefully, oh, yeah, like this. Also get rid of this. And put the print bed back on. Okay. At least I'm getting better in putting this on, I think. Just the nuts keep being annoying. Okay, number one. Why the bearings on the opposite side from the XY motor instead of the same? You mean why those are here instead of here? The reason was that basically I wanted to get around adding extra rods, because those are a little bit inconvenient to use as the Z rod, because the motors are kind of interfering here. So I would need to move them forward, I guess. Oh. Can't really put it down like this right now. So basically, if I would want to use these rods in the back for this, in the current setup, it's a bit tricky because of the motors here. Yeah, the motor is too close to the rods. So if I can change that, of course, right? So I can move the motors further in. I can prolong this motor bay just like outwards. To make space between the rod and the motor. But basically, if you look here, like there's very little space, and technically the motor can move a little bit further that direction if there's less tension on it. The other option is, right, like I can add like another rod here. It's just like I kind of want to, again, like keep it simple. So I can add some clamp here to like add a rod, and then like we need one on the bottom anyways, like something will be here anyways, then we can have like an extra one here. Like that's the other option I was thinking about. And that's the backup, right? So if this doesn't work, we have to use this rod. And I understand that this will solve a lot of problems. That's my understanding. Yes. But even if there's no tensioners here, right? Even if there's no tensioner, you still have the motor somewhere here. Yeah, it's just like, because I print the builder step by built the printer step by step, like I didn't have like a complete master plan for everything. So right now I kind of have to pay the price. I mean, you can always redesign stuff. I just then I have to also reprint all the parts. So I'm kind of looking for a solution that is easy, works with the parts I have for the most part. And yeah, so this is kind of like why I came up with this, but I think I have to give up on that. I mean, this works way easier. Way easier. Yeah, of course, that's torque. Like, there's not the lever. The question is now, like, what happens if we put weight here? Like, then of course it also becomes harder. Let's quickly try it again, like on the back. If I do the same thing here, just for me to feel the difference. Yeah, it's way harder to lift. The question is, can the NEMA 17 lift it? Right? Like, if it's hard, but the NEMA 17 can do it, potentially we are not having a problem. Yeah, but this is so much easier. If you put 1.5 kilogram there, it will be much better because the linear bearings will not twist as much. Yeah. The bottle doesn't fit because of that. But I think we can put it on the corner here. Yeah. It's no discussion. It's better. Do we need the belt on the opposite for stability? I wonder how it will be kept safe. Well, the thing is, that was also kind of like my thing, that if I have the belt here, put it on the far side. Yeah, exactly. Put it on the far side here. It's still like way easier. I mean, the belt, the bed now starts tilting like that. Of course. Actually, not that much. I mean, it goes down a bit. Yeah, but this comes down again to this part not being connected. Because basically what happens is here, like if I now put weight on it, you see this goes down. But this one also moves much closer to that. So if this is like rigid, like these two parts are rigid here, this helps a lot. Okay, so I guess then the front concept is just that. Like, I don't think we can make it work. The only thing, like, and that's something we kind of talked about in the beginning, right? And it's also like something Jonas now but I will be pretty bad for printing now. Like, you mean if it's flexing down, the more weight you put on? Yeah, definitely. The thing is just like at the moment it's flexing because like all those parts are individual, like they're not really connected. Like those two parts here that hold the two rods, they're completely individual. So I can, this is like kind of where the flex at the moment comes from mostly. So in the final part, this needs to be rigidly connected. Like this is one part. Then you lose this flex, and then this flex should also go away mostly. But it will be like a challenge. I think the thing is it's quite a bit big print bed for be put on 2 points only. Maybe zip tie both rods together for now. What's there did that? All my zip ties. We tried. It's not enough. So basically, like, we definitely have to make like custom parts for that. Like, also want to bolt it here together with the screws. That's not stable enough. So basically, this needs to be super stiff. If we want to have only one side supported. If you want to have both sides, like, my thinking is just like maybe this print bed is just too big for this setup. Especially because I'm not using like super rigid parts. Potentially this print bed is just too big. Because, yeah, I mean, even if we move it up here, there's quite a bit of flex. But also like the V0 print bed, right? Like, it doesn't have as much flex, but it has some flex. So I think some flex is okay. We just need to figure out how much flex is okay. But also coming back again, like to one point. If I have the belt here at the back, two rods there. I see the second one. If you keep the two bad middle rods, you can tie the bottom one with a spring to the bottom of the printer and have the M7 pull the upper rod to the top. So basically you want something pulling this rod also down, basically, right? So this one also be pulled down. My question is just because this belt will be tensioned, right? This will go back to here and will be tensioned. Isn't that in this point also pulling down? If you have a belt around, it pulls up and down at the same time. Yeah, exactly. That's also what I was thinking, Jonas. The belt only connects on a single point on the rod. In order to create torque, you must have 2 points. Yeah, but the belt is connected at 2 points, right? Like, if you look here right now, these are 2 points, right? It's like this point here and that point. And then on the bottom, it will go around the motor. So that was like where also a bit my confusion came from in the beginning, because I see that as 2 points. Maybe let's quickly just like demonstrate that. So if not sure how long this needs to be, but if I zip tie this together here, right? So if I put this here, right? And then the motor sits on the bottom here. My finger is basically the motor. This is not like a tad too long, but if I shorten this, my finger is the motor. These are 2 connection points, right? We have now one connection point that goes up and one that goes down. Maybe check the 2.4 gantries at first. Yeah, like 4 motors are out of the question. It's just like it's too much cost basically for the printer. That didn't work. But this kind of would be the setup, right? Minus the unexpected rapid drop. So basically this would be here and then the motor would pull. And I think this would provide tension up and down, right? Or am I missing something here? Okay, like I stop now because everything breaks. But this is kind of like the motion. And this works quite well. But it's hard to pull. I'm not quite sure, like partly this is just because like this is not really like with bearings and stuff, and my finger is not like the smoothest surface ever to run on. Okay, here's another question. What happens if we, instead of having the bed, like either way, right? The bed is off the, like this is the center basically of our like plane basically. So what if we position the bed differently? So if we would add more rods, let's just say like we don't use the front rods, we need to add rods somewhere, right? What stops us from positioning the rod that center, or like wherever the center of the print bed would be? So I guess somewhere around here. And then have those bearings be on this rod here. Because then basically what this would mean is the bed is basically positioned like this. Right? Then basically like the weight is center. And then like we can have the belt and there's still like a slide lever, but it's like way less. Because basically only half the print bed is off, like on the lever side, right? The other half is still on the bed. How will you make the belt to be at two connection points that are far away enough from each other to generate torque? Oh, you mean they need to be like spaced? Well, not with the belt, right? The belt can only go vertically up or down. Like that means the belts are completely like on top of each other, basically. I see what you're saying. The belt tension gives stability though, right? That's the only thing, but like it doesn't help with the twisting. Wait. Okay, this is now the last thing I'm testing. This might make it a bit harder to level though, but I think that's a worthwhile worthwhile compromise. And then this needs to move here. Nut. This is really fiddly. Where is the torque that is ability tech? It's only temporary. Like this is all like test setup. Like this is not progress. This is just we're trying to figure out how to mount a bat basically. We could have both rods to the end, then you could fix the belt on 2 points. Oh, you mean those 2 rods? That wouldn't like yes, but I can also have like a small piece that extends up and down from 1 rod. And then I hook the belt into the piece. That's not a big deal. The Rook has the same setup basically. They also use the belt. So for me the question is basically the main problem I'm still facing is we have like a lot of leverage because we pull at one side, which is here. Let me quickly grab another cable tie. So basically, single motor setup. Yeah, exactly. That's the challenge. Like how to move a big bat with a single motor. I mean, this is way easier to lift because now basically half the weight of the bat, right, is in front of the bearings and half is behind. So I think this would be quite a good setup actually. That would just mean we have to add like 1 additional vertical rod, like wherever the center of the bat needs to be. And then instead of the front rod, we ride on this rod here. And I think then we have like a very good compromise where we have only 2 axes basically, so we won't get into issues with binding having 3. And we have like an acceptable lever length basically. Because then basically it's only the 9 centimeters instead of 18, so we halved the lever, which I might be wrong, but I think it's like not linear. Like lever stuff is not linear, right? Like it's maybe square or something. So we might save a lot, like we reduce the force by a lot. Oh wait, we still have this calculator open. Torque calculator. So basically, the distance would halve, but also the force is different now because like basically that's not a thing, like assuming the weight is equally distributed on the bat, right? So if you have like tons of weight on the front of the bat, it's obviously different than having like a lot of force on the back. So if the weight is somewhere in the, like, the closer it is to the back, like if it's in this section, you have like a really short lever because like the weight is here, and you here, the lever gets harder. Like you have a longer lever, but then basically the result is you shouldn't print on the front tip of the bed. You should like more print center area-ish towards the back. The Rook has sort of a reverse triangle. But it also means you need 2 more from the front to the back. Yeah. So basically on the bottom we will have something like this anyways, Jonas. Like you will have like a square on the bottom, and then like the rod basically needs to go to that base to here. So I think that's kind of okay. It's just like I tried around adding like this extra rod because it's just like an extra rod. But then basically the other options would be to have the bed riding on the back rod, which is a bit tricky because of the motor, or the bed is riding on the front rod, what we do now. But if you have it on the front rod, you always pull from the back of the bed. But that means you have like a very long lever. So whatever weight is on the bed, like it's really hard to pull very quickly. Whereas if you have the bed riding on the back and you have weight on the bed starts to droop down very quickly. Like you have to build it very, very stiff to prevent it drooping. So basically the front has the downside lever, the back has the downside drooping. So I think the best solution is the center, because then you don't have any drooping, or like almost no drooping, because like the weight is kind of like evenly distributed on that. The other option that I had in mind, right, is the triangle, but also with the triangle you will have the same lever forces and less drooping because it's stiffer. But I heard from the Rook project that they had issues with like having 3 vertical rods with binding. The Rook has a sort of reverse triangle, right? The Rook, that's not a very useful Google search. Let's go into like literature research. The Rook, and this is like an old Mark 1. The Rook has basically 2 rods on the back, and then a bed in the front, and then there's a belt in the back. So basically between the 2 rods on the back there's a belt. But the difference between my print and the Rook is the print bed area, because the Rook only has the 120mm bed, whereas I have 180, so it's just bigger and heavier. If you do the middle, can't you also put the motor in the middle? No, I can't put the motor in the middle, Fabian. Jonas, sorry. Because then basically the belt needs to go through the print bed, right? The belt can only be in front or behind the print bed. We can't, I mean, we can cut a hole in the print bed, but I think it would be quite impractical. But you can't tie it to top rod because you need to clear the x-axis. That actually works. So there's enough clearance. I mean, we can also increase that, but there's enough clearance, at least for this like bracket I made at some point. Let me see. Oh, let me try to squeeze it on. Here we go. Like there's enough clearance for that. Oh, not anymore because I added screws to the bottom. But that's like a solvable problem. Like we can always increase the spacing here a bit. That's not a big deal. That's not a big deal. Technically, it also doesn't need to go like 360 rounds. Like it's enough if it clamps left and right. Like the vertical part is not super important. So with 2 bearings and the belt, the Rook has kind of 3 points of control in almost straight line. Yeah, exactly. So basically the Rook has the same setup that I would have if I would go for the riding on the hind rods and having the belt in the middle. It's the same setup. The problem is just that the Rook has a smaller print bed. I mean, quite a bit smaller, right? Like it's like 60% smaller. So it's just like way lighter than what I have here now. So I just fear if I do that, like I will get issues with like drooping down. And the moment it starts drooping, the bearings will start binding up. I mean, left or right side of the bed. Well, then you still get the same lever, right? The only thing, Jonas, that one could do if you say left or right, we can do left and right. Because technically we can install the motor in a way that it drives two belts on each side. Like for me, it's fixed. It needs to be one motor. We could argue whether we do two motors, maybe in a pinch, that are controlled by the same stepper, like a dual Z basically. But if we have like left and right, yeah, actually it's like not the worst idea. So basically, if we have one belt here and one belt here, we could couple it with like one motor, because it's kind of like one axis, right? So in the end, we need like some shaft that spins, and then like the two belts are connected to that. Yeah, exactly. One motor driving two belts with a long shaft. They also have a super beefy printed carriage. Their look at the printed piece is super big. Yeah, exactly. Like the Rook printed carriage, like the bed carriage is immensely heavy. I mean, I now, like after playing around with this for like the entire evening, I know why. Don't get me wrong. I absolutely understand why this thing is as big as it is. But now imagine we need to beef it up by 60%. So there are motors with alpha shafts on both ends. Yes, I know they are, but they're also quite expensive, Ballistic Tech. They are quite expensive, I assume. Like, while I dropped my 100 euro price point, I still try to have a design that is simple and cheap. So this should end up in the Rook price point. So, oh wait, here's actually, I don't have the files of the Rook. Oh yeah, see here you see it a bit better. It's also newer design. But here they have like, I mean, this is also now like with the extrusions, but you have like 1, 2 rods and then the belt in the center. And the smaller bed. Oh, look at this. I have no clue what this is. Oh no, but they also have front, back. Okay, now ignore me. It looked like for a second that they had like this like balance option in the center. Yeah, like here on this picture that you don't see. Open image in new tab. Here, look at this. I have no clue what printer this is. But they have like linear rails in the center, right? Left and right. But then also 3 motors, which again is out, but... or dual belt system, you can use gearing to prevent bed falling. Have a larger gear like on the 2.4 vertical belt. You can look at the Panda Mini. It has a pretty unique setup for that. Panda Mini. Okay, let's look at the Panda Mini. Oh, interesting. They have rollers. Oh yeah, but they have rollers and they have like V-slot extrusions, it seems like, right? But in only one lead screw, as far as I can tell. So basically, if we would find a way, I mean, from what I can see now, like I see two options. Not sure if it would work with V-wheels. Yeah, I know, like adding V-wheels now, like it's not really easy because I don't use extrusions. What I wanted to look at actually is the Ender 5. How do they do that? Because they have... I don't want to buy one. Because Ender 5... Yeah, look at this. What they do. They have one linear rod basically here, and then they have the lead screw. And this is somehow also working. It has a bigger bed than mine. Yeah, basically the Rook setup, but yeah, like they have one rod and one lead screw. Is there something... Now they have two lead screws, actually, like two rods and one. But it's just like, it's like a way sturdier printer, right? Yeah. Wait, there's a plus? Let's just check for review. Rook 180, yeah, that's also a good one. Rook 180, but I think they have like a try setup. Triple belted Z. Yeah, but this is kind of the setup that I had, right? I don't see the belt, but there's a motor in the back. Let's quickly open this, because I think that's actually a really good one, Jonas. Common mod for the Ender 5 is dual Z motors, yeah. I wonder why. 1 second, let me quickly open. Give me a second. I'm opening the Rook file, or the Rook 180. It's uploading slowly, very, very slowly. Let me see if I find more pictures online. Wait, there's a Rook extended 235. I mean, here you kind of see the setup as well, right? Like they use the 2 front rods and then they pull on the back. You see here like this like little tiny gap. This is where the belt mounts, and then you see here the motor. So that's exactly the setup that I want to do. And I'm not sure if I can do. Let's see. Yep, I have a Rook file to open. Let's get rid of this menu. Yeah. This is 100% what I have, right? They have the rod here in front, left, right. But it's a way beefier rod. Like this is a 12mm rod and I have 8. That's the only difference. Like this is like a fair bit beefier. And then here in the back, there's the motor. And then you can see the belt attaches exactly here. So the belt just loops around that, like goes in here and comes out here. And then it's just like zip tied together, basically what I just did as well. Yeah, and then you see here on top, there's like the idler. Okay, if the Rook does that, then I do that too. Let's just go for it. The thing is just like they have beefier bearings. That's the one difference. But then if you can extend the Rook to 235 and keep those bearings, I'm pretty sure that you can get the 180 working. The question is, does it need 3 Z motors or is it one? There's only one motor. Oh, you are correct. Jonas, you're correct. There are 3. 1, 2, 3. That's the difference. Shit. I didn't see that. Yeah. Okay. Then it's out. Because I don't have 3 motors. You mean just using this one on the back? It most likely can work. I'm just not sure if it works well. It could be that they did it for tilt adjust. Potentially they did. But it's like, it's kind of like what we tried that, right? Like we had the setup working, or like we still have the setup working here on my table, where we only pull in the back, and it's really hard to pull. It is hard because basically if the weight is more towards the front, right, like you have to work against the lever. What you could do, it sounds a bit stupid, but you could have a counterweight on the back. If you have something heavy on the back, then it balances out the heavy bed. But it's also kind of like a stupid approach. Okay, I think the best way forward is indeed the center. That we have the rods in the center of the bed. So the rods basically are centered. RC150, okay, let's do some more research. Jonas, you're like a repository, or like endless repository of printers. Wait, I don't want to build. Well, I only see his YouTube video, so let's quickly. Let me see if this. No, there's no images. Okay, let's quickly check out the video. No, there's no files yet, so it's not published. Ah, here. Yeah, this is actually a good idea. Thank you, Jonas. So how does it work? The motor's in the center. I need to 4 belts and 2 motors. But if it uses 2 motors like this, you can also use 1 motor, right? I'm watching too many videos. Maybe, but it's also a good thing. Wait, there's episode 2. I would just need to know what's in there. But I think that's an interesting concept. Because belt is cheap, right? Like we can use as much belt as we want, basically. Just checking where he puts the motor together. But there's some gear or something here. But it might just be like to reduce speed and torque. Oh yeah, it's just going from the motor to the large gear. so you have more precise movement. Okay, I'll check if we have files on that, but I think this is like a good, there are 2 gears on each side. Yeah. This might be a good option for us. Indeed. Because then you have on the 4 corners and you don't have a problem. The benefit of that would also be you don't need any... I'm not sure if he uses something to like guide us up and down. But technically, if you have 4 belts, you don't need any extra motion system, right? You don't need any rods. You don't need any bearings. It's just the belts. They're revealed. Yeah, could be. I mean, worst case, we can always use the bearings we have. But you could do a print piece. I mean, like for the vertical movement, like the bearings are fine. I also think we don't need the bearings on all 4 sides, because I think the bearings are only like to arrest the bed like in the XY plane. Okay, so here's the deal. I think we just have to try it. Like we just have to build it and see how it works. That means there are like 2 approaches at the moment that are, I think, good. Technically, we can try three things. The easiest thing, and I think we just need a motor. We need a motor to drive that, right? Like me moving it by hand is not sufficient. So the first is basically having the rod in the back. Let me just try to show it from the side. So the first is basically we have rods here in the back where it runs on, and we have a motor also on the same plane, basically with a belt. That's option 1. Downside is we could have drooping basically to the front. So the bed needs to be very rigidly mounted. But the Ender 5 is doing that, and it works. So, and the Ender 5 has a bigger print bed. So that is option A. It's quite simple, so I think that's something I would try first. Option B is we move the rod forward, keep the motor in the back. Then basically it's kind of like compromise where we get a little bit of lever or like we get a little bit of torque when moving up, less drooping. And option 3 is basically we do the belts in the like we do the rods in the center. I think we have 1 rod each side, but then we do the funky RC150 solution where we have 1 motor basically pulling on all four corners. Because the thing is, like, if we have 1 motor, we can always have like 1 long shaft going from one side to the other, and then 1 motor driving 2 belts that just touch all 4 corners. You need a Discord server for this, so I can send you video with timestamp. Yeah, that is true. Like, I was kind of low-key considering having a Discord server. But if you want to, you can also just add me on Discord. Then that's also simple. Let's see. Just drop me an email. Then we can exchange Discord stuff. Just drop me an email to my support email. Here you go. Just drop me an email there, and then we can hook up on or like link up on Discord. And you can send me videos like this because I think this is super helpful. Cool. Yeah, I think that's kind of like it for today as well. Like, so we have 3 options. Um, I would just try to come up with a better setup for this. That we have like still like prototyping phase. Like we have printed parts here, but then we also have a motor mount in the back. That's something I'll just prepare until next time. So next time, basically, we can use the main board we have to drive the Z-axis with the motor, and then just see how it behaves. Because like for me, like yeah, this is not proper at the moment because like it's super like wobbly because we have like all the different parts like kind of like loosely bolted together, and this is not proper, and nothing is nice. So if we have more rigid parts, I think this is way better. Then like next time, let's just try to have a prototype setup, but we use it with a motor, like that the motor drives that, because then we can just see how it behaves. Let's just start with the simple solution. Let's actually start with the center solution, rods in the center. That's, I think, quite a straightforward setup. And if that doesn't work, let's go with the funky 4-corner setup. But then we just need to figure out how to run the belts. Cool. I think that's it. Oh yeah, next week I'm not in town, so next week we'll have to skip. And then the week after, we either do that or we work on the switch wire. Because for switch wire, we need to extract motors. So the motors for the sprint will come from my switch wire. So we have to work on that machine to swap all the motors. Basically, we'll go from Bolden to direct drive. And that will free up 2 more motors we can use for this beautiful build here. Cool. Yeah, thanks everyone for tuning in. And see you in 2 weeks. Enjoy your weekend. Bye.